Golden section search is a general-purpose search technique for finding a local maximum or minimum of a unimodel function. In this tutorial, I'll be showing you how to find the local maximum. Here's our example function. F of x is equal to 8 times sine of x minus x cubed over 70. And we must rewrite it for MATLAB. So we have our function f equals 8 times sine of x minus x cubed over 70, and our ranges for x will be from -20 to 20. So the first part of the golden section search is setting a lower and upper guess. So our lower guess will be 0 and our upper guess will be 4. The next part is to find the golden ratio, and the golden ratio is the square root of 5 minus 1 all over 2. And then we take the golden ratio and multiply it by the difference of the upper and lower guess, and then we apply this new value found from multiplying the golden ratio by the upper and lower guess and add it to x lower, get us an x1, and subtract it to x2. Subtract it from x upper to give us an x2. And these are our possible new upper value and our possible new lower value. Here's just a simple plot of all the values that we have here. Now we move on to the actual search. We're going through 20 iterations in this search, so let's run it up so we can see what's going on. So in figure 1 you can see our different values. Our x1 value is here in black, our x2 value is here in pink, our x lower is red, and our x upper is in green. So to compute the golden section search, we must go through a set of conditions. We check to see if x2 is greater than x1, so x2 is in pink, as you can see it is above x1, which is in black, so our x1 becomes our new x upper, and our x2 becomes our new x1. Our x lower value will stay the same, and then we must compute d again to find a new x2 value. But if x1 was greater than x2, then x lower becomes x2, x2 becomes x1, x upper will stay the same, and we must find a new x1 value by taking x lower and our new computed d from our golden ratio for our new x1. So after you do that, each time our approximation will get closer and closer to our maximum value, as you can see in figure 2. Our upper and lower bounds in red and green are both approximating our local maximum between the points of 0 and 4 right here. And approximate values of x lower after 20 iterations is 1.5577, and it approximates our maximum to 7.9453, and our X upper value after 20 iterations is 1.5579, and it evaluates our maximum at 7.9453. And then we can always double check by going to Wolfram Alpha. As you can see, typed in the same function to Wolfram Alpha. It computed the same graph. And for our range, the maximum is 7.945, just as we found, at the point 1.55, which matches up with the same values that we found using the golden section search.